Compton effect, Compton scattering, expression for Compton shift with the derivation. A.H. Compton discovered the Compton effect in the year 1923, for which he got Nobel Prize of Physics in the year 1927. When high frequency of photon or radiation incident, they interact with the electron and are scattered by electron. The frequency of scattered photon is smaller than the frequency of incident photon wave. This phenomenon is known as Compton effect. The frequency of the scattered photon is smaller than the frequency of incident photon is known as Compton effect. The wavelength of scattered photon is higher than the incident photon. The wavelength of scattered photon is higher than the incident photon. The difference in the wavelength depends on the angle of scattering, and the effect of change in the wavelength of scattered photon is called Compton shift. About this experimental setup, we have a source here which emits the beam of X-ray is lambda, the incident wavelength lambda, and beam passes through the pair of collimators and falls on the some kind of material like graphite, and it's scattered in all various direction. It is detector which detects the material, this given material or given target material. Detector detects the material. Finally we got this kind of graph from this detector. Next point about this graph, intensity versus wavelength. Along y-axis you take intensity, along x-axis you take wavelength. Here we can see about Compton shift, delta lambda. Theta is small and Compton shift is also small. Theta is large, Compton shift is large. The wavelength for the large angle, the shift is very large. For the small angle, the shift is very small. This peak, the small peak is shows incident photon or incident wavelength. The large peak shows the scattered photon. In between, the difference between scattered photon and incident photon is called Compton shift.